So in this video we're going to do partial fraction decomposition when the denominator in the ratio can be factored into two distinct linear factors. So for the example that we have here, it says write the partial fraction decomposition of 5x over x squared minus x minus 6 and then use that decomposition to resolve this integral. So if we have 5x over x squared minus x minus 6, we want to recognize that the denominator can be factored as x minus 3 times x plus 2. So the denominator factors into two distinct linear factors. Distinct because they are different than each other. So if 5x over x squared minus x minus 6 can be rewritten as the sum of two ratios, the denominators are going to be x minus 3 and x plus 2. They're going to be the two factors that give us x squared minus x minus 6 when multiplied by each other. And then what we do for the numerator is we guess that the numerator is a polynomial that is 1 degree lower than the denominator, core denominator term that we have. So here we recognize that x minus 3 and x plus 2 are both linear or first degree polynomials. So we're going to guess that the numerators are 0 degree polynomials, or just constant terms or real numbers. Some real number A, some real number B. Real numbers are degree 0 polynomials. And then what we want to recognize is to get our common denominator, what we would have needed to do would be to take the product of these two terms. It would be an x minus 3 times an x plus 2. This product gives us the x squared minus x minus 6. And our numerator of 5x is going to be built by taking, we found a common denominator, so we need to get the numerator, which would be a times x plus 2, a times x plus 2 plus b times x minus 3. And because the two denominators are already the same, these two ratios will be the same as long as the numerators match. So what we need is 5x to equal a times x plus 2 plus b times x minus 3. So our job is, we have two unknowns. A is unknown and b is unknown. We're trying to figure out the sum of these two ratios. And so what we want to do is generate two equations, and the easiest way to do it is to pick values of x in a way that gives you equations in only a and b, but that does it in a clever way. So the first choice of x would be negative 2. Negative 2 is a good choice because if we plug negative 2 in for x right here, we'll get a 0, and 0 times a will make this term go away, and we'll have something that has just a b in it, and then we can solve for b. So go in, everywhere you see an x, replace it with negative 2. So we get 5 times negative 2 is negative 10, equals negative 2 plus 2 is 0 times a is 0. So we don't have to worry about that. Negative 2 minus 3 is a negative 5, so we get b times a negative 5. Divide both sides by negative 5, we get 2 is equal to b. And then we do the same thing again, looking for a smart value of x, and here looking at the x minus 3 factor, plugging in x equal to 3 would be a great choice because 3 minus 3 would be 0. 0 times b would be 0, so the b will have gone away, and we'll have something that has just the a in it, and we can solve for a. So plug 3 in for x here, we get 5 times 3 is 15, equals, plug 3 in here, we get 3 plus 2 is 5, so we get a 5 times a, and here we get 3 minus 3 is 0, 0 times b is 0. We step down here, divide both sides by 5, so we get 3 is equal to a. So now I know the values of a and b that would need to go here. So I go back to the integral I'm interested in evaluating, which is the integral of 5x over, I've got my screen angled down and it's throwing off my writing, x squared minus x minus 6 dx. But this ratio can be replaced with two fractions, a over x minus 3, a over x minus 3, plus b over x plus 2, and this will be dx. But we solved for a we discovered is 3, and b we discovered is 2. And then what we need to do is integrate these two terms. And what we want to recognize is that each of these is actually really easy to integrate. This first one is going to give us 3 times the natural log of the absolute value of x minus 3. And you could verify that by taking this derivative and making sure you get 3 over x minus 3 back. So notice the derivative of the natural log, if we have natural log of crap, we get 1 over the crap. And then we have to multiply by the derivative of the crap. The derivative of x minus 3 is just 1, and we're already multiplying everything by a 3, so we get 3 times 1 is 3 over x minus 3. So the derivative of 3 natural log absolute value of x minus 3 gives us back the original ratio that we had right here, plus this guy is also going to be a natural log. He's going to be 2 times the natural log of the absolute value of x plus 2. Again, you could verify it by taking this derivative and making sure you get this ratio back. And then, of course, we need plus a constant of integration.